We're going to open the meeting here in a second and move forward with the EHT presentation, and we'll be back online with you when we're ready for your item.
Okay, sounds good. Will I be able to listen in to the presentation?
Yes, sir, and if you can't for some reason, just email me or text me, and we'll get right on it.
Okay. Because pretty much everything in my letters, all I've got to say, other than if something happens in that presentation, I want to comment on.
Very good.
I'll be on standby.
Yes, sir. Thank you.
I'll now call this meeting of the Sweetwater City Commission to order. Ask Commissioner Lee to give the invocation this morning, and Commissioner Peak to lead us in the pledges.
Join me in prayer. Father, we do thank you for this day, for your graciousness, for your provision of cooler weather and the changing of seasons. You're such a loving God, and we thank you for that. We pray that today that in our deliberations you would give guidance, you'd give us keen insight, you'd give us leadership, you'd strengthen our resolve and help us to move forward in a direction that would be pleasing to you. Thank you for those that have come today, and I pray that we could do all this in your will and in our conscience, that your guidance would be felt and understood. We pray all this in Jesus' name. Amen.
Amen.
Please join me in pledge to our nation and state flag. I pledge
allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Honor
Under the Texas flag, I pledge allegiance to thee, Texas, one state, under God, one and indivisible.
Thank you all for being here this morning. We'll now move to item 4A, which is to hear a presentation from Mr. Sage Diller and Mr. Rick Castleberg on elevated storage tank project. We'll begin with Mr. Diller.
Do you need this, Sage? Yes. There you go.
Good morning, Mr. Mayor, Commission. For the record, my name is Sage Diller with EHT, here to discuss the status of the elevated storage tank. We've got a few slides here put together, and we'll move right into it. I may be crazy, but if I was a betting man, I'd be willing to bet that you guys have gotten some questions around town on what's taking so long to get the older tank down and off of the system operation. And so I'm here to explain that. Ultimately, the short and brief version of it is we had a design error on our plans that increased the height of the tank that gave about 8 psi increase to the system. Well, 8 psi is really not that big of an increase, but when you have areas of town, especially on the north side, that have already 120 to 130 psi, then there's some issues and concerns there. That can lead to increased risk of line leakage and line breakage on the water mains, and so we want to come to you guys with a proposed plan for addressing that. Here's an outline of what we're going to cover: system information, a little bit of background on where we started and where we got to and where we are now. The technical memorandum that we developed for this situation, kind of a in-depth analysis of the system, the distribution system and the operation, the hydraulic evaluation and calibration and updates of the model, and then a proposed plan forward. Okay, you guys have seen this slide before. This is basically the intent is to show the main terrain change across the system on the bottom profile. On the left-hand side, the left-hand side are where the tank locations are. You see the natural ground as it starts from higher elevation on more the south side, and then as it goes through town on the north, it's much lower. Obviously, that increases the water pressure. The tanks are generally designed, the TCEQ regulation, are designed so that you have a minimum of 35 psi at your highest connections. So when you start looking at your tanks, you need to account for that. In systems where you have big terrain differential, If you're going to meet your minimum requirements on your higher elevations, obviously you're going to have, higher elevations at your low elevations. So what we're proposing to do is account for that. What we're looking at here is a pressure plane separation, which is not uncommon. This is what we're proposing today is not anything that is not already installed in systems across the nation. Multiple pressure planes and PRVs are common practice when trying to regulate pressure across a distribution system. I think that's all I wanted to cover on that slide. So when the pressure, 8 psi pressure increase, let me go back right quick. The north side of the system up there, north of the railroad tracks, is really the lower area, the older parts of the system that already have 120 to 130 psi in the system already. So, you go and you add 8 psi to that, that does not make that situation any better. There are portions down on more of the southern side that they may have 45 psi and an 8 psi increase, that'd be welcomed. And then, that's not even going to be, that would be welcomed, that increase of pressure. But obviously in areas that are high already, we need to address that. So the technical memorandum that we developed, we started with some calibration of the hydraulic model, going back with staff and looking at the water system, looking at line connections, valve placements, getting pressures in the system, pressures off tanks, just making sure that we did our due diligence on evaluating the system. We worked through this technical memorandum, found the summary from the existing conditions, the existing system with the new tank, and then how these proposed improvements can benefit the system, not only mitigate the pressure increase, but also benefit the system as a whole. The proposed improvements that we have identified there, isolating the pressure plane into 2 sections right along just south of the railroad tracks. We're proposing to install 2 PRV stations, one at Neff and Avenue A and one at Poplar and Broadway. Installing a fill control valve on the Robert Lee standpipe, which it had in years past. There had been a fill control valve on that tank. We feel it's going to be beneficial having it installed so that you can control the operation of those 2 tanks better. And then some line work there at the Robert Lee standpipe. Now, what we are proposing, as I mentioned, that we had the design issue, we increased the pressure, the system 8 psi. We were proposing to accomplish these improvements at our cost. We think it's going to be beneficial, not only addressing the mitigation of the pressure increase, but it will be beneficial for the system at whole. So that's what we're proposing here. Here are some graphics of the proposed improvements, the locations. There on the inset up there in the north, or the top right, there's an inset there shown, a proposed PRV station there at Neff and A, and then some of the valve, isolation valve modifications throughout the central part of the system. And then next, on the next slide, are the improvements at the Robert Lee, which is the field control valve, the piping improvements, and then also the PRV station there at Poplar and Broadway. This is part of the hydraulic model results, showing the pressure ranges in the system that were existing. As you can see, this is with the new elevated tank in place. There's a lot of red up there, which is above 95 psi in the northern part of the system. And then with the proposed improvements that we have identified, as you can see, there's a widespread improvement all in that northern area. The proposed improvements are to mitigate the pressure increase on the north half. So you can kind of see as I flip back, that's current or with the new tank, and then that's with the proposed improvements. Our recommended strategy is to work closely with staff on implementation of these proposed improvements, keep the commission informed and informed of the progress and anticipated schedule, and then, develop a map of the installed improvements and operational guidance manual once those are complete. And that's our proposed path forward. If there are any questions or anything else I could do at this time, be glad to.
I have a question with regard to, I think it's that slide right there that
Yes, sir.
shows a pretty good group of red, which is 95 plus
Yes, sir.
on the southeast side of town.
Yes, sir.
What's your plan to mitigate that?
Those are high existing. Now I'm saying we are adding 8 psi to those. We feel like the system can handle that small increase in that area. It's not as big as a burden as what is on north of the tracks, but that area will see a small increase in pressure.
So the red areas there are after the repairs that you're gonna do?
That's correct.
Okay.
And keep in mind those pressure ranges, that may be 95.2, but they still show up as red.
Right.
And as we move further north, as the elevation falls off, the pressures ranges increase significantly.
The reason for my question is that's my side of town.
Yes, sir, I understand that. I understand.
And the ones that are right downtown, or just south, is that on Lamar and to the east of Lamar, it appears? Is that right? That group of red that's right in the middle of the,
South of the tracks?
yeah.
Yes, sir, I believe that's the location.
It's
Now,
hard to tell on the map because,
right, and it's hard to get those graphics out of that hydraulic model on here so they can display
Sure.
large enough to see everything. But yes, now, so if you look at an 8 psi increase, if there's already 90 psi there, you're talking about less than a 10% increase. It's not anything crazy. I get more concerned when we're looking at the 120s, 130s, and now you're adding 8 psi to that. And especially in area town where you have some aging lines, the likelihood of main breaks increases.
When we attempted to initially fill the elevated storage tank, were any of the line breaks in the area that Commissioner Lee's asking about, or were they all northeast?
My understanding is they were further north.
Okay.
Now, and keep in mind, there have been PRVs installed in portions of the system already that are operational and working. There's one down on Newman Street, which covers some of that red area, I believe. And, the upstream, the reports I got upstream, the incoming pressure was like 100 to 110. With the PRVs installed, it stepped it down to 65. And those are adjustable. You can change those PRV settings on there. If 65 is not enough, you can go up a little bit. But those have been performing as planned.
So Sage, I guess, has there been some mitigation already done to
Yes,
the
sir.
system?
That's
I
correct.
guess
Yes.
in my area, I live in north part of town, and
Yes, sir.
I know my pressure has dropped significantly, and
Right.
I have some neighbors who now don't have enough pressure to even run their sprinkler systems.
Right.
Is that gonna be resolved when all of this is done? Are they gonna be able to run their sprinkler systems again?
Every sprinkler system is different. What the whole intent of stepping that pressure down is to reduce the strain off the city's infrastructure, where they're already seeing high pressures in some old lines. You have increased line leakage and line breaks. So the intent of using those PRVs to step down that pressure is to reduce that burden on the city's system. Individual sprinkler systems all operate differently. There may need to be, most likely need to be some adjustments on those irrigation systems. They may have been put in with the idea that we have 100 psi of incoming pressure, 110, and that's the way they were designed. There can be some minor adjustments to those to account for a lower incoming pressure. But incoming pressure of 60, 50, 65 psi is very, very common. So it's not like the whole irrigation system will be, unusable. There may have to be some modifications the way they have their valve set. But keep in mind, the city's, the whole intent here is the focus on the city's infrastructure, the water mains that the city controls. And the city does not control private yard systems.
When I read the text that y'all had produced, I was confused about the Robert Lee standpipe and the issues that existed prior and the issues that y'all plan to fix. Can you kind of touch on that?
I will
How
do
that's gonna work?
Yeah, I will do my best. It is kind of a interesting or difficult interaction between those two. Currently, the water comes into the point of entry, and the path of least resistance is to the Robert Lee standpipe. So it has made it. The staff has done a great job of finding ways of operating those two tanks conjunctively. But there's a point where if you were to try to fill the existing elevated storage tank, it would overrun the Robert Lee standpipe. And so they have done a great job of finding that happy spot and keeping pumps running and operating the system so that doesn't happen. What we are proposing now is to put a field control valve on the inlet side of that Robert Lee standpipe. And in this investigation, years and years ago, there used to be one. And so what that will allow you to do is once the height in the Robert Lee reaches the set point where we want it, then that valve will close, and it'll essentially create some back pressure that then allows to fill the new elevated storage tank. And so what we're proposing, and I believe staff is on board with this, but we'll have to work through that, but is switching the controls over to the main new elevated storage tank, which is a bigger, wider spot in the line. That's the term we use, a wide spot in the line. But you have a greater volume in the air that gives you a little bit more float on the system. The way it currently operates off of the Robert Lee standpipe, because it's a smaller, pintle-like structure, it's a tube, it has a real narrow, when there's demand in the system, it fluctuates quickly. So a lot of times you have to have pumps running to maintain that system demand. Now there's going to be a larger volume up in the air in the new elevated storage tank, which gives you more buffer. And the intent, and most common operation or distribution operation, I would say, try to tend to run your system off of the larger volume tank that you have. You can fill it in low demand periods overnight, and then when demand hits in the morning, you're kind of fed off those tanks, and we'll have to find the happy spot of when the pumps need to kick on and fill those, but it'll just give more buffer to demand, to reaction to demand in the system. Does that?
Yeah.
It is a pretty intricate relationship between those two, but we think these improvements are going to be an improvement to the overall system for sure.
Those will be, or that pressure release valve or fill valve for the Robert Lee standpipe can be controlled by computer, and can it be controlled manually if there's a need, if for some reason it overflows and won't stop?
Right. You're correct. All the valves will have manual control on them, but these will run hydrostatically. They will be based upon the pressure in the tank.
Okay.
And then you have a setting on there. Once it reaches that desired pressure, which is basically height in the tank, the valve will close.
It'll shut off.
And then when it drops down, the valve will open. And we're proposing to tie into the SCADA system that will report those settings or the operation back to the HMI at the water plant, so they can see that.
Good, thank you.
Yes, sir.
Have y'all completed all the design and engineering work that will need to be done, or is there still more to be done?
We believe all the work has been done. I'm not saying that there won't be new information that will come about while this process moves forward. There's always things in the field that come about that we will need to be reactive to, but we feel like everything's been done and we're ready to get going.
And all of this is done at y'all's expense?
That's our proposal, yes, sir.
And when you say that includes design, purchase of all new valves and the new 12-inch water pipe, installation,
Yes,
Is
sir.
that correct?
Yeah, those items that are listed, those improvements that we've shown. Correct. You know, we're expected to be perfect, and we expect ourselves to be perfect, and unfortunately, we are human. I think the important thing is when things come up like this, we need to step up and address them, and that's what we're proposing to do.
The city's incurred some legal and engineering fees as a result of this. Do you have any plans to address those?
I believe that has been worked out between the parties.
Okay.
We'll have, once we step into executive session, we'll have an opportunity to discuss in more detail with Mr. Chapman, some of those issues, the financial issues.
Sage, how does the cost of this plan compare with fixing the tower at the height that it should have been? And what would be involved in
Yeah,
fixing
cou-
the tower
A
at
couple of things there.
the correct height?
Couple of things there. It's more common to raise a tank than it is to lower a tank. Typical people like to have more pressure, and if you have too much pressure, typically valves are put in place to address that. That tower, in coordination with the tank manufacturer, the cost of lowering that tank would basically be almost the same as, or not even a little bit more, than building a new tank. It just doesn't really make sense to go down that road, in our opinion.
Any other questions?
Well, I guess is one of your proposals, we're putting in all of these valves. What about the future maintenance and replacement of these valves as time goes by?
You know, we've worked with the valve reps from some of the biggest companies, talking about what is a typical maintenance plan on one of these, and it just varies. It varies system to system. It depends upon the quality of water, depends upon the pressures in the system, depends upon upstream line breaks that may get debris in the line. One of the companies told us, typical maintenance will be every 3 to 7 years. Now, he recommends more of inspecting them every 2 years for optimum performance. They have some of the parts and pieces inside of the valves themselves are really not that expensive. There's some diaphragms in there, some O-rings and different things to be replaced. But the main body of the valve is what is on the initial purchase, and those will last very long time. That's part of our plan, is to, if we're able to move forward, get some of the valve reps in to have discussions on typical operation of these valves and O&M and all that good stuff, and that way the staff is informed and up to date, and we're up to date, and we have a good common plan going forward.
What are those valves made out of, brass or what? What's the material?
Usually ductile iron, they're coated ductile iron with epoxy coating, which is typical for water systems.
Well, you've answered my questions. I appreciate it.
Yes, sir.
Very succinct and I think to me it looks like a good plan.
Thanks, sir.
Yes, sir.
Okay, now we'll turn to Mr. Rick Castleberg to give us information on the item.
And just some
Okay,
background.
this,
I'm sorry, Rick, if you just give me 1 second, I just want to introduce you. Just some background on Mr. Casperg's involvement in this project. What we wanted to do from the city's perspective is get someone on board that has good information and experience with these types of systems. And the name of KPA Engineering was brought forward by Mr. Chapman. And we agreed to bring Rick on board and his firm on board to help us vet the solution that EHT just proposed to you. And so at this time, we have Rick on the phone with us to go over his thoughts after reviewing all of the data and all of the materials that were provided to him, and share his perspective on whether him and his firm believes that the solution is a viable solution for us. So Rick, with that, I'll turn it over to you.
Thank you, David, and, good morning to the mayor and council members. Y'all, you each should have my summary letter that we published as a result of our review of Sage's work and the proposed improvements. So I'm gonna go through a few items I put down as Sage went through his presentation, just for additional comment. And first of all, Sage's comment that PRVs are a common practice in the water industry is absolutely correct. I've worked on many municipal systems, and the PRV pressure zones created by PRVs are a common practice in probably all the clients we work for here in Central Texas. In fact, City of Belton, most of their entire system is, their pressure zones are created by PRVs. So I just wanted to add that comment for the council as assurance this is no patchwork, if you will. In regards to the area north of the railroad track, we discussed or asked, has there been any fire flows modeled with the proposed improvements? And really what you want to do there is put some fire demands in your model in the far reaches and different areas in that created zone north of the railroad to make sure you can meet the International Fire Code of 1,000 gallons a minute with the residual pressure during a fire demand of 20 psi. I don't know if they've gone back and checked that. I would suspect it should meet that, but I think it'd be worth a check to make sure you don't find any supply issues to that zone. One question about when y'all discussed some residents experiencing issues with their sprinkler system now. My question is, has there been some interim improvements or valve turning that's caused the pressure to be reduced in that northern zone today?
We got Mr. Campbell coming up to the microphone here, Rick.
Yes, sir.
Morning. Yes, sir. What we did though is, we added 3 PRVs over there at Haley Street, back during the building of the elevated storage tank. That was designed originally to go in, and we reduced the pressure over there, like Sage said, from about 110 to 120 down to about 65 originally, and now we brought that pressure up to about 70, 72 pounds. And that entails from, say, Haley and 14th out to Santa Fe and Haley, then back to the north. Those 3 PRVs control that. Okay?
I would think, as high as those pressures are, that any issues you have with people's sprinkler systems, you could adjust the overall system pressure to eliminate all those issues, I would think. But I just thought it was kind of odd that somebody said their sprinkler system's not working, because any sprinkler system should run as it's intended to with pressures of 50 psi or so. So that just stuck out in the conversation why that is occurring. But
Rick, I think what it was, a lot of people was running quite a few heads, on one zone.
yeah,
Instead of separate the zones like they'd be able to run at 50 or 60 psi, they want to run like
Yeah.
the whole front yard, or the whole backyard,
yeah.
in one zone. And
Well,
you really need to separate those.
yeah, when you had the 100 PSI years ago, they could do that. You know, run an entire yard on one grid. If you're gonna reduce that down, that may be what's causing the issue there. Kinda surprised me. That was my comment on that. In regards to the Robert Lee standpipe, I'm very familiar with those kind of schematics, the control valve. I might add that if you're having that in your SCADA system, that, and this is real easy to do, it's just programming, is you're gonna have your on and off settings. I would probably add a third setting that's an alarm signal. Say you tell the valve to open at a certain low water elevation, the tank fills, and it turns off at whatever the setting is on the high water level. I would probably have that high water level 6 inches or a foot below the overflow of that tank. And that's where I would set the alarm that says, hey, the valve is not closing for some reason, we're overflowing the tank. And it would just send a signal to Eddie or one of the operators that you're in alarm condition. And that's a common, Sage, you may already have that plugged in, so that's pretty common practice. Also, I'd like to comment about the discussion about the new tank and lowering the tank. I want to add this comment that the improvements y'all are considering today are much better, regardless cost comparison, what have you, than messing with that tank. If one was cheaper or more expensive than the other one, I would still do what you're considering today. And in fact, and Sage alluded to this, some of the higher ground elevations, that will be an enhancement to those areas. So I would not go any further in discussing modifying that tank. That's not a feasible option, nor is it worth doing. What you're looking at today is a much better solution. And then lastly, on your PRVs that you're proposing to install, we typically would put some bypass piping around that PRV. And I don't know if that's planned or not, but it's pretty common, because what you want the ability is, you want a valve on each end of the PRV that you could close. You open the bypass, and that gives you interim service while you're maintaining a valve. Say you need to take one out. Well, you close the valves on each side of the PRV, remove the PRV, do the maintenance, open your bypass so you're still serving water to town, to these areas while you're doing maintenance on the PRV. Y'all understand that?
Understand it, but does that risk elevating pressures too high during that maintenance period?
Well, what you could do is don't open the valve all the way. And really, essentially what you're creating, that bypass valve is kind of like a manual PRV, if you will.
Okay.
You're creating artificial friction that makes the pressure come down while that PRV is not in there. Same function of a PRV.
Okay, thank you.
You just can't set it. You'd have to use some caution in those rare situations. And we're talking about something that may not happen once every 7 years, if that. But for the time, eventually, 20 years, 15 years from now, eventually equipment, just like a lawnmower, you gotta go get a new one. So they're gonna have to be replaced way down the road. you know, I've got clients that have PRVs that are probably 25, 30 years old. But eventually, just like anything we use, we eventually have to replace it. And that's generally my comments on all of this outside of what I published in my letter. And I'd be glad to answer any questions.
So Rick, just in sum, your confidence that the EHT solution is the best solution is high. You have high confidence in that?
I have very high confidence in it.
Okay, very good. Thank you.
It's done a good job with it.
Thanks, sir.
Mm-hmm.
Okay, we'll now move to item 4B, which is to enter into closed session pursuant to section 551.071 of the Texas Governmental Code.
Move we enter, closed session.
Second.
All in favor?
Aye.
I don't think that guy read the report. Everything he was saying is in the report. It doesn't look like he read it like he should have. That'd be disturbing to me if you paid him $15,000, $20,000, maybe $25,000 to do that. He didn't have a clue. We knew more about what was going on. Don't you agree?
Well, it kind of sounded